Section 4.7 is graphing apps or special functions. There are three different types of special functions that we will focus on: absolute value functions, step functions, and piecewise functions. In Algebra 1, our focus is mainly on the absolute value function and the piecewise functions. We will get more into step functions in Algebra 2. Today, our focus is going to be on graphing absolute value functions. Absolute value functions will always be, the graph of an absolute value function will always be a V. It will not be a straight line, not a curve, it will always be a V. In order to graph these, we are going to use an XYT chart. My rule of thumb is pick a positive, a negative, and 0. Positive number, a negative number, and 0 to get us started. You'll have to pick a lot more points than that, but that's just a good place to start. So we are ready to go ahead and substitute some of our values in to find our Y values. So let's substitute 1 in for x into our function. We can take 1 minus 3, the absolute value of 1 minus 3. 1 minus 3 is negative 2, and the absolute value of negative 2 is 2. So our first ordered pair is 1, 2. Over 1, up 2. Substitute the next x coordinate in, negative 1. So negative 1 minus 3 is negative 4. And the absolute value of negative 4 is positive 4. So I am plotting my points as I get them. It will help you to find mistakes because you'll notice that point is way off. It doesn't really jive with the rest of the data. So I would encourage you to plot your points as you are finding them. The third value is 0. If we substitute 0 in for x, the absolute value of 0 minus 3. 0 minus 3 is negative 3, and the absolute value of negative 3 is 3. 0, 3. Right now it looks like our points fall in a straight line, but that's not going to be the case. It's going to make a V. I would encourage you to pick additional points greater than 1, and maybe a few that are less than negative 1. Let's start with values that are greater than 1. 2, 3, and 4. If we substitute 2 into our function, we have 2 minus 3, which is negative 1, and the absolute value of negative 1? 1. So our next point is at 2, 1. Of course, that seems to jive with the rest of our data, agree? Seems to fall on that line as it looks. Let's keep picking points. Substitute 3 in. The absolute value of 3 minus 3 is 0. The absolute value of 0, of course, is 0. So we have 3, 0. Again, it falls in our line, so we know we're on the right track. Let's substitute 4 in. The absolute value of 4 minus 3. 4 minus 3 is 1, and the absolute value of 1 is 1. So our next ordered pair is 4, 1. Okay, what did you notice about that last point that we plotted? It started to go up. At this point, it may have just been a fluke. Maybe we made a mistake. I would not just go or base the rest of your graph on one point. Pick additional values. I'm going to put in the next two numbers, 5 and 6, to see if this trend does continue. If we substitute 5 in, we have the absolute value of 5 minus 3. 5 minus 3 is 2, and the absolute value of 2? 2. So we have 5, 2. Substitute 6 in. 6 minus 3, absolute value of 6 minus 3 is 3. The absolute value of 3 is 3. At this point, I think that we're safe to draw in the line that goes through our points, or the V that's going to go through our points, because it's pretty well clear what our graph is going to look like. So please take your pencil and draw in the line that goes through these points. I want you to use all of your graph. Don't make a teeny tiny little V. Extend your arrows onto the ends of the graph. Now, in addition, we need to identify the domain and the range. There's a couple of ways that you can think about domain and range. Let's first tell you what they are. We talked about domain and range when we talked about functions. And something else I want to add in here is that this was in function notation, correct? Our problem? F of x equals the absolute value of x minus 3. That f of x indicates that our graph, our problem is in function notation. So the graph must be a function. How do we determine if our graph is a function or not? Good. The vertical line test. So we could, of course, apply the vertical line test, and this graph would pass the vertical line test. It touches our graph in only one place at a time. It wouldn't touch our line in two places. So definitely make sure, number one, it is a function. Number two, domain. Domain is your input values. What numbers can I put into this function? I put in -1, I put in 1. 0. Could I put in fractions? Could I put in 1/2, 1/3 if I wanted? Okay. Could I put in more negative numbers? Alright, so let's describe our input values. What numbers could we input into this function? Huh? Every number. How do we say that if we want every number? Every number, if we could, we could put anything we wanted for x, couldn't we? We were just picking numbers that could. Huh? Our input values, we're going to say our domain is all real numbers. That indicates that we can put anything we want in for x. And we were able to do that. Now, the range is our output numbers. Input is what we put in. Output is what we get out. So when we put in, look at your XYT chart. These numbers in the left-hand column of your XYT chart are the input numbers. We can put anything we want in. But we don't necessarily get anything we want out, do we? For example, did we get any negative numbers out? We could have gotten decimals and fractions. We just chose to put in integers. So that's going to result in output of integers. How can we describe the numbers that we're getting out? They're all positive. Now what about 0? Is 0 a positive number? It's not considered a positive. It's not negative either though. Whole numbers. Okay, but remember whole numbers don't include fractions and decimals. And we probably could have gotten fractions and decimals had we inputted a fraction or decimal.
All but negative numbers.
How could we say that? Say that?
Not all real numbers.
True. True.
It's not.
Can't just list all of our numbers, can we? Because there's too many of them. I'll give you a hint. We're going to use an inequality symbol. Our range values are our output numbers. Y in our XYT chart is our output number, correct? Okay, so that's why I'm using Y. I'm going to say that my output numbers are greater than or equal to what number?
0.
0. Our output numbers are greater than or equal to 0. If you would look at your graph for a second. Look at your graph. I think it's easiest to find domain and range just by looking at our graph. Our y-axis is right here, correct? That's our y-axis. So what is the smallest y value that we have?
0.
Well, it's right here at 0, isn't it? This point right here is our smallest y value. Well, what is the y coordinate here? No, the y coordinate, not the x coordinate. The y coordinate is 0. All these other points have y coordinates that are bigger than 0. They're all above 0, aren't they? On our axes. So let's think about domain in the same sense. Our domain is our input numbers, correct? Well, our input numbers are our x values. So what x numbers could we put in? Well, I'm going to start here. I'm just going to look at half of this graph. I could put in, obviously, 1, 2, 3 is 4, What are my input numbers? 5, 6. Could 7 be one of my input numbers? It's on the graph. What about 8? Could that be an input number? Yes. 9, 10. What about 99? Could that be an input number? Do the same thing with the other side of your V here on the left side. Could I put in -2? That matches my graph. What about -3?
Yeah.
Yes. Okay. We can put anything we want into these functions. The domain is always going to be all real numbers. The range is going to vary based on your graph. So today I'm looking for you to graph with the domain and the range. Let's look at another one together. We'll do this one. No, actually I'm going to do one a little more. Let's do this one. See on that, I believe it is the bottom left-hand graph on your notes. Alright, so if we want to graph this, what method do we use? XY chart. We get to select values of x. Remember, I would recommend starting with 0, 1, and -1. It kind of gives you a good starting point. You're going to have to pick more than that, but it's just a good starting. So substitute 0 into your function. 2 times 0 is 0, and 0 plus 2, 2. And the absolute value of 2 is 2. So our first order pair is at 0, 2. Substitute 1 into your function. 2 times 1 is 2, and 2 plus 2, and the absolute value of 4, 4. Our next order pair is 1, 4. How about -1? 2 times -1 is -2, and the -2 plus 2, and the absolute value of 0, 0. So we have -1, 0. Right now, it looks like my points are in a straight line. Is that going to be the case? You have got to make the mental note that if it has absolute values, value bars, it's going to be a V, and you've got to pick more points. What do you think? Should we pick positive values or more negative values?
Negative.
Why do you think that?
Because you'll just go on one side.
Are you thinking that you know what the right side of the V is going to look like?
Yeah.
We need to pick somewhere and see where it's going to go. I don't know if it's going to go up here, but it might go up there. All right, so that's a good thinking. Good thinking. So let's pick some more negative numbers. Maybe -2, -3, -4. So substitute -2 in. 2 times -2 is -4. -4 plus 2, -2. And the absolute value? +2. So we have -2, +2. So it looks like it's going to go straight back up already. Let's see if that holds true. Let's put the next 2 points in. Substitute -3 in. 2 times -3 is -6. -6 plus 2, -4. And the absolute value of -4? 4. So we have -3, 4. Substitute -4 in. 2 times -4 is -8. -8 plus 2, -6. And the absolute value of -6 is 6. Do our points fall in a perfect V? So that one was okay. Guys, your graph must be symmetrical on the right and left sides. This point of the V right here is called the vertex. If we were to draw an imaginary line down the middle of that vertex, the left and the right sides of your V should be identical. They should be symmetrical. And if they're not, something's probably up with your graphing and you need to make sure that you plotted your points correctly or maybe you did your algebra correctly. So let's take this on. Let's find our domain and our range. Remember, domain is your input. What kind of numbers could we put into this function? All real numbers. We could put anything we wanted. Could have put fractions, decimals, positives, negatives. So we're going to use the symbol of all real numbers. our range is our output. Let's look at our graph to help us with what numbers we could get out. Our vertex here is the lowest point on our graph. So where does that match? What is our lowest y value, I should say? -1 is not 2. That's our x value. Where does it meet the y-axis? 0. Everything is 0 or higher. How do I show everything is bigger than 0? Y is greater than or equal to 0. Y in our XY t chart, the Y column of our XY t chart is our output column. So our output numbers are greater than or equal to 0. You can look at your graph and see that the smallest Y value is at 0. Alright, I'm going to stop here so that you guys can get started on your homework. If you need to ask questions, you can do that. I have 4 problems for you to practice. Page 265, 17 through 20.